Hey, hi everyone. Hello. Am I audible? Can you just quickly confirm if I'm audible? अरे send me first code हो गया contest खत्म. Contest खत्म. It is over, guys. Audible and visible. Perfect. We're 415 watching. That's amazing. I will wait for a couple of minutes till everyone joins in and then we will get started. How was the contest? 10:30 तक ही था ना? 10:30 तक ही था ना? Ignore the mess at back. Bachelor's room. Third wala was a part of Euler tour. Second was prior simple. The second was very easy. First was again very easy. I think third one was good enough. Like if you have done computer programming, you will be able to solve that problem in 1 minute. If you are into CP, the third problem is like 1 minute and it's done. Once you read the problem, it's like it aise banega. Second, I will say if you are into lead code a lot, then it will be easy for you. The first one was very basic. वो पीछे टॉवल सूख रहा है क्या? नहीं नहीं खुद खुद सब कुछ करना पड़ता है, थोड़ा टफ है लाइफ, बट ठीक है. Maybe you someone commented I'm a candid master. Maybe you have not read about Euler tour. Once I tell you the solution, be like easy tha. Don't worry. Okay. I'll just pick up. Okay, here goes the tab. I'll share my screen. Super quick. लाइट थोड़ी कमी है क्योंकि आज यहाँ पे क्लाउडी वेदर एंड माय रिंग लाइट हैज नॉट येट अराइव्ड, so my face might not be that bright as you feel like, but it's fine. 904 watching. Oh, that's amazing. So okay, solve problems. Let's go to the first one. Okay, I'll give you like some minutes, let's say, assuming that a lot of people did not solve it. So please go through this problem. Let me tell you the solution of third. You'll find it easy. Give me some time. Okay, presentify का है मेरा. Okay, दिख रहा है? स्क्रीन दिख रहा है? लिख रहा हूँ तो दिख रहा है? दिख रहा है, सही. क्वेश्चन पढ़ते हैं. Okay, so the question says the thief lives in linear land where everything exists on a single dimension. अभी comments थोड़ा बंद कर दो. You can just stop commenting. For everyone new out here, it's the Job-A-thon 11 editorial. Okay. So there are n police stations in the city. So there are n police stations in the city. The ith police station is located at the coordinate xi. So they're basically saying in a line, let's say one police station is here, the other is here, the other is here, the other is here, and the other can be here. So it's a linear line where every police station is occurring on a integer coordinate. Okay. Now, there is Geek who lives at coordinate A. Assume the coordinate A is here, where the guy Geek lives. Okay. The distance between Geek and the ith police station is given by absolute of A minus, basically difference of the coordinates is the distance. Now, thief wants to choose two distinct police stations. So the thief exactly wants to select couple of distinct. Assume he selects one here, assume he selects one here. So once he selects, there will be a value. Basically, this will be a difference which will be A minus xi and there will be this difference which will again be a minus xj, and then you have to add it up. So basically if you take this example like 4 5 and a is 1, so it's like 4 minus 1 plus 5 minus 1. I decided to select 4, I decided to select 5, and there was 1. So 1 minus 4 and 1 minus 5. And the value that it gets, it's 7. And the value that it gets is 7. Now your task is to, like, you might be given n number of police stations. Your task is to select couple of police stations such that, I repeat, you have to select couple of police stations such that a minus the first police station plus a minus the second police station, definitely absolute of both is maximum. Yes, is maximized. That is what the question states, is maximized. Okay, so if I ask you a simple straightforward logic, that how do you maximize, so let's trim the problem down to just one coordinate and then we will think of other things. If I ask you a minus xi, I want you to maximize this portion. I want you to maximize the absolute value of A. Now we know that it's a linear line. We know that it's a linear line. A will be somewhere here. Can I say, if I'm deciding to choose on xi, I repeat, if I'm deciding to choose on xi, my brain will say, Striver, if there is A, xi, I'll either choose the leftmost guy to be the xi so that this difference is maximum, or I'll either choose the rightmost guy to be the xi. Does everyone agree with this? The initial logic. If I'm looking to maximize a minus xi, my priority will be to choose the leftmost guy as the xi, and my priority will be to choose the rightmost guy. And either of them can be my answer. Like either this will be maximum or this will be maximum. No one in between can be maximum. No one in between can be the maximum. So something that I can figure out is I definitely need the leftmost guy, maybe, or I definitely need the rightmost guy, again, maybe. So the first assumption or the first observation that I figure out is, in order to maximize something in terms of a minus xi, I need the leftmost guy or the smallest guy, and I need the largest guy. And then I need to compare. I need to compare. I need to compare, right? Either the smallest will give me the maximum value or the largest will give me the maximum value. That is something which I definitely know, right? Now the question has been extended into a longer version. And the longer version states, okay, over here you have an xi and you now need to choose one more xi. So the question has been elongated into slightly longer version where they say, okay, you have an absolute of this. Now I want you to select one more guy. I want you to select one more guy. So it's a repetition. Whatever is this guy is similar to this guy, right? So what I can know is there is one smallest, right? Then there is one largest. So can I say this? Can I say this? That if I have two elements to choose, if I have two elements to choose, and there is clearly written one thing, please read this line properly. I think there's somewhere written they have to choose two distinct values. Yeah, please read this line. So you cannot choose two smallest. You cannot be like, okay, I'll assign this to here, I'll assign this to here. That's not possible. So if that's not possible, if for one you will choose smallest, for the other, what can you choose? What can you choose? Obviously, second smallest. Obviously, second smallest. If you're not allowed to choose smallest because they've clearly stated you need two distinct. So can I say one can be smallest while the other one can be second smallest? Similarly, if you're deciding to choose largest, can I say, okay, I might choose largest or I might choose second largest? Do you agree? Guys, do you agree? How many of you do agree with this? That we need smallest, we need second smallest, we need second largest, and we need largest. So these are the four variables that will matter to us. How many of you agree? Can I get a yes? Spam mat karo yaar comments mein. Spam mat karo comments mein. Please don't spam on comments. Let's study. Agreed. So now I know one thing. What I care about is smallest, second largest, and largest. I only do care about this. I only do care about this. And what is the expression that I'm solving? What is the expression that I'm solving? A minus xi plus a minus xi. This is the expression that I'm solving. So I can say, okay, maybe this one goes here and this one goes here. That can be one of the way. Or I say, okay, maybe this one goes here and this one goes here. Okay. Or maybe this one goes here or this one goes here. That might be the case. Or this one goes here and this one goes here. Or this one goes here and this one goes here. Or this one goes here or this one goes here. So can I say, I just need to make sure I need to select two guys which gives me the max value. I need to select two guys which gives me the max values. Out of four guys, I need to select the two guys which give me the maximum of this, comma this. How many of you have understood this? How many of you understood this? Can I get a US if you have understood the solution? Can I get a US? Yeah, there can be multiple different ways. See, there can be multiple ways to solve a problem. I'm telling you how I approach this problem. There can definitely be multiple approaches. There can be a different approach as well. I'm telling you the approach that I thought of the moment the question came up. Okay, so I can say sort. थोड़ा बड़ा कर लेते हैं. Sort x dot begin. Looks like everyone has understood. Perfect. X dot n. So this is something which we'll do. Now I know something for sure is I need n is given to us. Is n given to us? Okay, n is given to us. So I need a vector int the elements equal to x of 0 is the first smaller, second largest, and largest. Either let's check out if n is greater than 2, so this will not give you runtime error. N is greater than 2, so you can definitely write this is definitely. But if by any chance you get lesser than 4 elements, by any chance if you have lesser than 4 elements, then just assume element to be the array itself. Once you have done this, you can definitely keep the maximum to be 0. All right, and now what you can do is you can just iterate from here to element dot size, and you can go on like this. Again, there can be multiple ways. उस पे बहस नहीं करते. There can be multiple ways, guys. Doesn't matter, because even if a is equal to each of the values, you're trying the farthermost value always. That's why you're taking 4 values. Okay, so you need to figure out a val equal to absolute of a minus element of I plus absolute of a minus element of j. And once you've done this, if this val exceeds your maxi, you can simply say maxi equal to val, and then you can just return it. Sorry, return val. This is something which you can do. Perfect. You can do a difference because I think someone mentioned in the chat you can do a difference. I said there can be multiple. I'm trying out 4C2 combinations, so the complexity is very small, so it's fine. 7 था क्या इसका? 7 था, हाँ सही है. So I'm trying 4C2 combination, which is hardly like 8 combinations, like not even 8. So it should be okay. It should be okay. Like the complexity is very, very, very small. So even if you do anything else, then also you have to use sorting, and then you have to again do a linear iteration. So it's kind of nc2, like n log n plus 4c2 over here. So there can be different ways you can definitely try out. Again, you can definitely try out your ways, guys. Okay, let's move to the next question. So everyone done? Let's move. Shall we move to the next question? We can do this in big of, and I'm not sure because you have to apply sorting. I am not sure how will you do, because have they given it in the sorted or no? भाई इतना धीरे क्यों बोल रहे हो? धीरे बोल रहा हूँ क्या? आवाज नहीं आ रही है? Then I'll use my AirPods. आवाज धीरे आ रही है क्या? आवाज मैं बहुत जोर से चिल्ला रहा हूँ. अरे माइक कभी नहीं आया, फ्राइडे आएगा माइक. तो once my mic comes in Friday, then it will be okay. Is the आवाज okay? Is the आवाज okay? आवाज is okay? Okay, perfect. Arey, anyone who, arey, whatever you have done, it's fine. Because the like we have n equal to 10 to the power 5, so it's fine. Okay, let's move to the next one. So I'll just try to read this question. Just read the next question, please. Sound is slow. Okay, okay, we will see. Earphones लगा लो. I think सवारी. Okay, let's go to the next question. I'll ask you to read the question. I'll not try submitting. I'm just giving you the approaches because I'll go to submitting. फिर कोई error होगा. There's a lot of wastage of time. I don't want to waste time. I'm giving you the solutions because सारे ही approach problem setting में use किए गए. Whatever approach the problem setter has given, like while setting the problem, whatever approaches have been thought, I'm just presenting you the same solutions so that you get the idea about the problem setter, like what the problem setter thought when he did set. अकाउंट बनाओ, सबमिट करो, छोड़ो. सबमिट कर लो यार, खुद सबमिट कर लो, क्या जा रहा है. So there's something like maximum absolute of largest minus absolute, yeah. Array, you can do it in big of 1 as well, big of n as well. Instead of sorting, you just manually find smallest, second smallest, largest, second largest. Manually in big of n also you can find, right? You can always find largest in big of n, so that's fine. बच्चे वाले क्वेश्चन में क्यों पड़े, ये क्वेश्चन करो ना. Let's have the next question, okay? In case if you want to do it in big O of n, it's also possible. Instead of sorting, just write a for loop in order to find the largest and the second largest element. So you can easily do it without sorting as well. Like sorting is an easier version so that you save time. Otherwise, just find the second largest, you see, second largest element in an array in big O of n. There's a method. You just have to use couple of if else statements, couple of extra if else अगर आप लगा दोगे तो हो जाएगा. ये देखो यहाँ पे नहीं है, ये रहा. ऐसा करके आप सेकंड लार्जेस्ट निकाल सकते हो बिग ऑफ एन से, एंड उसके बाद यू कैन इजीली अप्लाई दैट. तो बिग ऑफ एन सोल्यूशन ही है. टू नॉट कॉम्प्लिकेट, आई जस्ट डन इट अ सॉर्टिंग मैन. ओफ मैन, बच्चों वाले प्रॉब्लम में सब. चलो अब इसमें दिमाग लगाओ. तो इतना ज्यादा चिल्ला रहे हो, इस पे चलो, तो ज्ञान दो, इस पे ज्ञान दो. राइटिंग की मत यूज करो. ओके यार, ये स्ट्रीम एड पे कौन चेंज कर देता है बार बार आके. ऐसे ही रहने दो यार. Don't change it. Don't change it. If anyone from the team is changing it, please don't change it because that hides the input. Read the question and then we'll move to the next one. You can alter the actual array, that's your choice. When you're giving an online assessment, no one cares what you're doing. But when you're giving an interview, then there is an issue. So at that moment, when you're giving an interview, it's important that instead of sorting, you'll say that, okay, I'll do a linear iteration and find the largest and the second largest. Shashank, that is problem setter's solution. You can try it afterwards. That is problem setter's solution and that is accepted. That is problem setter's solution that is already accepted. तुमने कुछ गलत किया होगा, तुम बाद में चेक कर लेना, ठीक है. कमेंट में स्पैम करके फायदा नहीं. You would have done some mistake, so keep a check afterwards. Okay, let's understand the question. So the question states, Geekland Coliseum. So the king of Geekland has ordered to build a Coliseum for fighting. For the inauguration, he asked his ministers to bring in 3N fighters. So the array is of size 3N. Okay. Each fighter is denoted by a roll number from 1 to 3N. So like 1, 2, 3 till 3N. An array of length 3N is given such that the ith element denotes the strength of the fighter with ith roll number. Okay. From these fighters, N fighters will be removed. Okay. So out of 3N, you have to remove N fighters. The remaining 2N will be divided into two groups based on their roll numbers. Very important. Once you remove N, once you remove N fighters, there will be 2N fighters remaining. Okay. So out of those 2N fighters, you have to figure out N fighters with the smallest roll numbers will be put in the group 1. N fighters with the smallest roll numbers. Smallest roll number means the first N that survives, you have to take them. And then the next N that is there, you will take them. Okay. And then two groups will fight against each other. So the first N will sum up to give you S1. The second N will sum up to give you N2, S2. Just a minute. यार ये just give me a minute. ये कौन है, ये पका क्यों रहा है इतना? एक बंदा है. I'll just कोई नहीं. So you have 3N, and if you subtract, you will get N elements. Sorry, 2N. So the first N, and then you have to take the next N. This will give you S1. This will give you S2. Okay? And on subtraction, you have to make sure, not absolute, on subtraction, you have to make sure this is as maximum as possible. This is as maximum as possible. So have you understood the question? So for an example, if you look at this example, you had the array like this. Okay. So they decided they will delete this. So once they've deleted, there are 4 elements left. So the first 2 elements will give you a sum of 8. The second 2 elements will give you a sum of 2, which ultimately yields a difference of 6, which is the maximum possible. Okay. And the next step, what you see is you have 1 1 5 3 7. What they decide is they subtract 1 and they subtract 7, maximum possible. Question. UQ if you've understood the question. UQ if you've understood the question. UQ if you've understood the question. It's not kind of a DP solution, but yeah, like you can call it a DP because you are going to store something. You are going to store something, so you can call it a DP. But the maximum implementation is over here of heap. Is over here of heap. Krishna Rao, you understood the question wrong. Pick up the first 2 elements and that will go into the bucket. Then the next in the saying subtract this will go and this will go to 8 minus is minus minus then minus instead of both small two, there is a 6 get sorry I dropped off because my internet was off. अब दिख रहा है सही है आवाज. So where did I अब आ रहा है अब आ रहा है अब आ रहा है ना. तो talking of this example, a lot of people ask me this example. So it's like 1,1,5,3,7,7. You need to understand, if you delete these guys, this will yield me a sum of 8. This will be yielding me a sum of 14. So 8 minus 14 is going to be equal to minus 6. 8 minus 14 is going to be minus 6, which is definitely not greater than minus 4. Minus 6 is smaller than minus 4 for a reason. That's why what they do is they are deleting minus 1 and 1 7, so that this 2 will give them 6 and this 2 will give them 10, which will give them minus 4. Okay, got it. अब लैग नहीं हो रहा है. पुराने वाले सब देख रहे हो, पुराने वाले कमेंट कर रहे हो, अब लैग नहीं हो रहा है. ठीक है. Understood why you can't select the first two? Understood why you can't select the first two? With live streaming, the problem is लैग तो नहीं हो रहा है मेरे आईपैड में. तुम लोगों को लैग क्यों हो रहा है? मेरे आईपैड में तो पूरा मस्त चल रहा है. Is it fine, like for the live users, is it fine? I'm assuming there are previous users who are saying me lag हो रहा है. I'm assuming there are previous users जो लोग बोल रहे lag हो रहा है. लैग तो मेरे को हो नहीं रहा, तुम लोग को कैसे लैग हो रहा है? मेरे आईपैड में मस्त आ रहा है. It's fine, right? अरे द प्रॉब्लम इज कुछ पुराने यूजर से, मतलब जो लोग लेट ज्वाइन किए वो लेट लाइव देख रहे हैं तो अभी कमेंट कर रहे हैं, तो इसलिए. ठीक है. सो द आइडिया ऑफ द क्वेश्चन इज you have to pick up the first n elements and you have to form a summation s1. You have to pick up the second n elements and you have to form a sum s2, and you have to keep s1 minus s2 to be as greater as possible. That's the idea. You have to make sure that this particular s1 is taken from the first n elements and this s2 is taken from the next n elements, and then their difference is as big as possible. Okay, is as big as possible. So if I ask you, if I'm looking to have s1 minus s2, not an absolute, just s1 minus s2, if I'm wanting to have s1 minus s2 as big as possible, what is your tendency? You'll be like, Striver, then my tendency will be to make s1 as big as possible and make s2 as small as possible. Greedy nature. I will try to increase the value of s1. I'll try to increase the value of s1 as much as possible, and I'll try to decrease the value of s2 as much as possible. Make sense? Make sense? Make sense, everyone? Just a minute. I'll ask them to. कुछ लोग जबरदस्ती स्पैम कर रहे हैं, तो मैं ये कर दे रहा हूँ, धीरे लगा दे रहा हूँ चैट में. जिनको पढ़ना है आराम से पढ़ो, बाद बाकी कुछ चिल मारो. सो कैन आई से दैट यू हैव टू मेक s1 as big as possible. So if you want to make s1 as big as possible, can I say these n elements, the first n elements that I pick should be the largest n elements, and can I say these n elements that I pick should be the smallest n elements? Can I say this? Have you understood? Have you guys understood? Have you guys understood the core logic? Have you guys understood the core logic? Rashaputra Prabhudeep, 7 plus 7 is not allowed because you have to pick S1 will be from first only. You can't say this guy is to go into S1. You can't say pick 7 and 7 and pick it into S1. That is not allowed. Out of the remaining elements, the first elements will go to S1, the next elements will go to S2. You cannot take 7 and 7 and put it into S1. That is not allowed. Please read this portion of the question. Please read this question. Smallest whole numbers. So if you're taking 7 and 7 and you're saying put it in S1, that's not allowed. Because before 7 and 7, there will be 3 and 5, na? Or there will be 5 and 1, na? That will go to S1. Got it? Got it, everyone? Okay, perfect, perfect. So everyone has got it. So our core logic was to make S1 minus S2 as big as possible. Our core logic was to make S1 minus S2 as big as possible. So now let's take the example, the second example only. Let's take the second example and explain. So 1, 1, 5, 3, 7, 7. Okay. For an example, let's assume I just put a random border over here. I put a random border over here. Okay. And I say out of these, select n elements. I say out of these, select n elements that will go to S1. And I say out of these, select n elements that will go to S2. My brain will say, okay, if out of these elements, I have to select elements that will go to S1, I'll try to maximize S1. So I will select 1 and 5. Like, okay, because I was asked to select two elements. So I'll select 1 and 5. So I'll just eliminate this so that I get S1 as big as 6. I cannot make it greater than 6. That's practically not possible. And I want to make S2 as small as possible. So I'll say, okay, select 3, which is the smallest, and then the next smallest is 7. So I'll make 10. So apparently, I'll get minus 4. I will. So, okay, I picked up two greatest element. I picked up two smallest elements, right? So I'm getting a logic. If I can try this for every partition, something like 1, 1, 5, 3, 7, 7. So can I say the first partition that I can try is over here? Because if I'm doing a partition here, from here I can pick two elements for sure, because what I need is two elements from the front, two elements from the back. So I can definitely pick two elements, and those two elements will be 1 plus 1, 2. And out of these, I can again pick two elements, which are the two smaller ones, 3 plus 5, 8, which will give me minus 6. Because I need to pick, this will give me S2, this will give me S1. So this can be one of the partitions. This can be one of the partitions. Or I can be like, I'll do one partition here where I'll pick 1 and 5, and I'll pick 3 and 7, which will give me again 6 and 10, which makes it minus 4. Or I can say, okay, let me go the other way and say I can do probably a partition here. And from here, I'll pick two largest elements, which is 5 plus 3, 8. And I'll pick two smallest elements, which is 7 plus 7, 14, which gives me minus 6. So apparently, this is the last case that I can do. Why? Because I can't go and do a partition here, because if I do a partition here, I can select two elements, 7 and 5. But from here, I will not get two elements. So I can only do partitions over here, or over here, or over here, right? And then I need to see which n plus which other side of n gives me the maximum. Is the logic, intuition, thought process clear? Is the logic, intuition, thought process clear? Is the logic, intuition, thought process clear to everyone? Can I get a you? Like, yes, just a yes. Solution I haven't told yet. Is the logic clear? Got it? So you need to understand, you cannot pick this 7 and this 7 and put it into S1. That is illegal. Illegal है, कर नहीं सकते हो. क्वेश्चन में बोलता है कि अगर इस 7 से पहले कोई बंदा है वो पहले S1 में जाएगा, तो ये साथ और ये साथ नहीं आएगा, ठीक है? So we need to create two groups. But one thing is sure, the first group will come from the first elements. Okay, perfect. Looks like everyone has kind of got an idea. So can I do something? Can I do something like a prefix array? Because, okay, what prefix? Prefix largest. So what I'll do is, I'll take a, by the way, in case you haven't checked out this question, sorry, in case you don't know this, this question will be using the logic of kth largest element. Yeah. So you need to know this kth largest element in an array, which uses a mean heap, So you have to go through this question. Okay, you have to go through this question, kth largest element in an array, and then you have to come back to this. Okay, just in case you don't know kth largest element, how to find that. So the problem will be requiring kth largest element array concept. Okay, cool. So as of now, let's see the example and try to do a dry run. So if you know kth largest element, well and good. If you don't know, then also well and good. ठीक है, आंसर की डॉक नहीं यार, प्रॉब्लम सेटर की अप्रोचेस है. वी कांट टीच एनीथिंग ना, प्रॉब्लम सेटर ने जो सेट किया वही पढ़ाना होगा ना. चलो, so this is given 115377. So assume this is the priority queue. Okay, assume this is the priority queue. Okay, so what I will do is I need two largest elements at every stage, because if I'm creating a partition here, I'm taking two largest elements and putting it into S1. If I'm creating a partition here, I'm taking two largest elements and putting it into S1. If I'm creating a partition here, I'm taking two largest elements and putting it over here. If I'm creating a partition here, I'm taking two largest, putting it here. So I need two largest elements at any moment. So at first, I'll keep a summation equal to 0. Okay. And I'll create a prefix array. I'll create a prefix array. Okay. Let's create a prefix array. So initially sum is 0 and I am having 1. So priority queue is empty. I'll just put on 1 over there. Next, I get 1. Again, priority queue is just having one element. And by the way, update the sum to 1. Next, I have 1. So I'll again put 1 and I'll update the sum to 2. Next, I have 5. Very, very important point. Very, very important point. So as of now, your priority queue contains two elements, right? And 1 is the two elements. But if I ask you, out of these 5, out of these 3, which are the two largest elements? Then answer comes 1 and 5 are the two largest elements. So what you'll do is, you will say priority queue, this is a minimum priority queue. Take out the smallest element, because as of now, you had two elements. I want you to throw the smallest element out because I got someone greater. I repeat, I want you to throw the smallest element out because I have got someone greater. Someone greater will give me more sum, so I'll keep him. So what I'll do is, I'll throw the smallest element out. So I'll throw the smallest element out. The moment I throw it, the sum will reduce by that much. And now I'll take the 5 and add it to the minimum priority queue. So the sum will increase to 6. So as of now, till here, the summation was 2 of two largest elements. Till here, the summation is now 6 because two largest elements are 5 and 1. Next time you get 3. So as of now, your minimum priority queue is containing 1 and 5. So you will be like, hey, I've got 3. I've got 3, which is greater than 1. Why are you keeping 1? Throw him out. Keep 3. I'll be like, okay. So if you throw 1 out, the sum will be 5. And if you add 3, the sum will be 8. So the new summation till here is 8. Perfect. Next, you get 7. You'll be like, oh, I got 7. Now I have 3 and 5. Remove the smallest 3 and I'll take 7. So if you remove 3, the summation will reduce to 5. And if you add 7, it will become 12. So the summation till here was 12, which is obvious because 7 plus 5 is 12. Next, you get 7. This time, the priority queue has 7 and 5. You'll say, throw 5, take 7. So the two greatest elements will become 14. So have you understood how do you get two largest elements at every step? Have you understood how did you get the two largest elements at every step? Has everyone understood? And two largest elements gave you this prefix large sum. Have you understood? Priority queue gives you the smallest. You don't need to keep the smallest in memory. If you use a minimum priority queue, it will always give you the smallest in memory. It will always give you the smallest in memory. You don't need to do anything else. Everyone has understood. Perfect. So I've got a prefix array which gives me the summing up the two largest elements every time, or k largest elements every time, right? Perfect. Right, perfect. So next, I need to create the opposite, because I know from here I need n larger, but from here, in order to create S2, I need n smaller as well. I need n smaller as well, right? I need n smaller as well. So what I'll do is, okay, I have 1, 1, 5, 3, 7, 7. So I'll create the same thing, suffix, and I'll say, okay, I'm over here. So when I'm over here, I'll take this 7 and put it into the priority queue. and my summation will be 7. But I need two elements, so this will be empty. Then when I'm over here, because I'm saying I'll do a partition here, because I'm saying I'm going to do a partition here. So what I am saying is, which are the two small elements? So I add 7. I add 7 over here. Okay. So the moment I add 7 over here, it's very important to understand one thing over here. If I'm trying to add 7, how much sum it will increase to? 14. It will definitely increase my summation to something as 14, obviously. So what I will do is I'll be like, okay, over here, 2 smaller till here is 14. Perfect. I'll do the same pattern. You need to understand one thing, guys. I'll do the same pattern of reverse. I'll do the same pattern of reverse and store smaller from this angle. So this will be 14. This will be 7 plus 3, 10. This will be 3 plus 5, 8. Because those are the two smaller. This will be 3 plus 1, 4. So can you fill suffix small from the left? Can you fill suffix small from the left in a similar fashion? Can you fill the suffix small? So this is suffix small, and the prefix was something like this. The prefix was 2, 6, 8, 7, 5, 12, 7, 7, 14. Right? So I will fill the suffix small in this order. I will fill the prefix large from this order. Right? Correct? Correct? So once I've done this, now it's a very easy stuff. Now the problem becomes cakewalk. I will start from here and I'm like, okay, this is the 4, which is S1, and this is S2. Okay. Next I'll go here. Right? Next I'll go here. I'll say this is my 8. Correct? Sorry, you got it right, what I'm meaning to say. So basically, you take the prefix max and you take the prefix sum. And this is, I'm not sure why will you use DP? How will you use DP? Because yeah, this is kind of DP because you're storing, right? So memoization, you're using memoization. How will you get those two array? You, as I said, you have to understand this kth largest in an array, and then it's a sliding window concept that you have to apply. So apparently ये S1 अगर मैं यहाँ पार्टीशन करता हूँ, S1 2 है और S2 8 है. अगर मैं यहाँ पार्टीशन करता हूँ, S1 is 6, S2 is 10. If I do a partition here, S1 is 8, S2 is 14. So you can easily get S1 and S2. Okay. I mean, if you've understood this. That was a tough question. It's kind of not DP, it's kind of priority queue plus prefix suffix. You can't say it as DP. This is not DP. It's kind of priority queue. Okay. See, if you want, then तब तो तुम इसको भी DP कह लो. Prefix sum भी DP है. मतलब ऐसे तो फिर Fibonacci is also DP. ऐसे तो फिर Fibonacci is also DP because you store the previous two versions. So yeah, if you want to call it DP, you can. That's your choice. Okay, understood. Okay, understood. So if I just quickly code this up, shall I code this up? How much is the time? I'll take 45 minutes. So क्या दिया हुआ है? Okay, n दिया हुआ है, 3n दिया हुआ है. ठीक. So okay. So if you want to code this, you just need to take this, then prefix max, okay, of n size. You can just initially you can keep it as 0, and then you can keep suff small, something like n plus 1 equal to 0. And then what you can do is you need the summation to be 0. Go to third question. Shall I not code? Shall I code? Shall I not code? I have the code. If you want, I can give you a read through. If you want, I can code it. जो बोलोगे कर दूंगा. मुझे मेरा कुछ नहीं जा रहा है. अपन का कुछ नहीं. Shall I code? Shall I not code? Shall I code? Shall I not code? Or do I read through the code that I have? or do I read through the code that I have? Tell me quickly. Tell me, quick. अरे यूज पाइथन. जितने लोग यहाँ पाइथन जावा छोड़ रहे हैं ना, अमेजन आपके लिए नहीं बना है. पाइथन जावा सी प्लस प्लस क्या होता है? लॉजिक होता है यार. डू यू राइट एनीथिंग एल्स इन जावा? जावा में ये भी लिखते हो. पाइथन व्हाट विल यू राइट? यू विल राइट समथिंग लाइक व्हाट विल यू राइट? प्रीफिक्स मैक्स. यू राइट दिस इन पाइथन ना. 0 into n plus 1. क्या तीर मार दिया? राइट दिस ओनली ना इन पाइथन. 0 into n plus 1. इडल. क्या मतलब? बच्चे ऐसे मत करो. ओके चलो कोड इट प्लीज. चलो लोग बोल रहे हैं कोड करने, तो कोड करता है. तो बेसिकली व्हेन यू स्टार्ट विद द फर्स्ट एलिमेंट, what you do is, first thing you will do is you will प्रायोरिटी क्यों इतना बड़ा डिक्लेयर करो. सिंटैक्स भूल चुका हूं. क्या था? वेक्टर इंट. सिंटैक्स क्या था? ये था ना सिंटैक्स. the syntax for this was the syntax for priority queue in. This should be the syntax. I forgot the syntax because nowadays I code in Java, so I don't remember that much, but it's fine. So as long as your priority queue does not have this, you can just go on by pushing the element into the priority queue. So you can just show problem setter code and move on to the third. Increase font size. लोग बोल रहे कोड कर लेना, कोड कर लेते हैं. फटाफट कोड कर लेते हैं. टाइम ही लगेगा मेरे को, ऐसे चला. तो if your PQ size, if your priority queue is still not having n elements, there is no doubt, just push it and add it to your sum. Okay, if your priority queue is still not having n elements, just take it and push it. Okay, this is what you'll do. Okay, and right after this, what you will do is, in case your priority queue is having a size, let's assume it's having a size of exactly n. Okay, in that case you need to see if the new element that comes in is that a greater element. जो छोटा बंदा मेरे पास already है ऊपर, उससे बड़ा है. If it is, then what you do is you first subtract the top element from the sum. Okay, then you pop it out. Then you say, okay, sum, can you please take that a of I? Then you say, okay, now you can go to the array of a of I. This is what you'll do, right? And once you've done this, what you can say is prefix of max of I can go as sum. Simple as that, right? So basically what I did was I kept on pushing it till I did not have any elements. If I have any elements, then I'll see जो छोटा बंदा है क्या उसको फेंक के नया बंदा ले सकता है. जो छोटा बंदा है क्या उसको फेंक के नया बंदा ले सकते हैं? अगर ले सकते हैं तो फेंक दो और नया बंदा लेके उसको डाल दो, एंड फिर जो समय है उसको जोड़ दो. Similar thing you have to do in the reverse order. Yes, similar thing you gotta do in the reverse order as well. So similarly, like you have to start from here and you have to go like this, and what you can similar thing, same thing you have to do in the reverse order, but this time the priority queue will be the greater priority queue. It will be the greater priority queue. That's the maxi. You have to use maxi. Do the same thing but in the reverse order. Okay, do the same thing but in the reverse order. This time you'll check क्या ये छोटा है तो बड़े को फेंको, छोटा ले लो, क्योंकि n छोटे एलिमेंट्स चाहिए, छोटा ले लेंगे. ठीक है. So this is the same thing you'll do. The same thing you'll do. Okay, I greater than equal to 0 गया. सही है. Once you have done this, you need the maximum. So you can probably keep maximum as minus 1e9. कितना है यहाँ पे? 10 to the power 9 है, 10 to the power 5 elements है. Okay, so if I take all the summations, 10 to the power 5, okay, minus 118. Now what you can do is you can just go across starting from n elements, because that's the first place where you will get the first round of elements, and you can just go on till something like this. I will not go to do syntax errors वगैरह, क्योंकि उतना यहाँ पे suffix max एक होगा. ठीक है, suffix small ले लो, prefix max हो गया, suffix small. If you do this and if you just return the maxi, should be fine. Should be somewhere around this. So priority queue means it's a max heap. It's a concept. Priority queue is something which stores the maximum element at the top, and if you do it in the opposite fashion, which is this, it'll keep the minimum element at the top. So line number 48 कैसे सोची? ये इसलिए सोचा क्योंकि देखो 10 टू द पावर 5 एलिमेंट्स थे, ठीक है। बता दो कैसे सोचा, कितने एलिमेंट्स थे? 10 टू द पावर 5 थी एलिमेंट्स, और सारे एलिमेंट्स बोले 10 टू द पावर 9 है। तो इमेजिन करो सारे एलिमेंट्स 10 टू द पावर 9 हो गए, लाइक ऑल द एलिमेंट्स आर 10 टू द पावर 9, इमेजिन ऑल द एलिमेंट्स 10 टू द पावर 9. So maximum what you can get is like 10 to the power 9 into 10 to the power 5, which will be yielding on 10 to the power 4, 10 to the power 14. So to be safe, I took minus 180 to be safe. Got it? So to be safe, I took minus 180. So second will be somewhere around this. I'll ask the problem set rolling the code in the description. It'll be somewhere around this. I'm not going to compile this because definitely I'll get some compilation, but logic will be this. ठीक है, पढ़ाते पढ़ाते code करना is going to be tough for me. So I'll just move on to the next one. Should we move on to the next? Should we move on to the next? Shall we move on to the next? I'll give the code link in the description. Same ही code है, same ही code है. Code link description पे मैं डलवा दूंगा, चेकआउट कर लेना, ठीक है. I'm not going to submit it because I've been teaching, and while teaching I might have done some silly mistakes. Might have, not sure, might have. तो मैं उसका रिस्क नहीं लूंगा, बट हाँ लॉजिक यही है, लॉजिक यही है, ठीक है. नेक्स्ट में मूव करें. मैंने बोला ना, देखो ये सब आएगा, इसीलिए मैं नहीं किया था. प्रैक्टिकल, हाँ, you'll have to go like P2, यही सब इसीलिए मैं नहीं कर रहा था. यहाँ पे P2 करो, P2 करो. Have you understood? Has everyone understood? Has everyone understood the logic and everything? अरे कर लेना भाई, इतना तो कर ही लोगे सर, ये सब ठीक. Shall we move to the next question? What if the number of elements are odd? It doesn't matter because n is given and they're saying you 3 into n will always be given. So how does it matter? Okay. हाँ, वो लॉन्ग के चलते यहाँ पे वो एरर है, ठीक है, मतलब कर लेना. चलो नेक्स्ट क्वेश्चन पे चले. बट सबको समझ में आ गया ना? ब्रूट फोर्स सोल्यूशन इसका क्या होगा? ब्रूट फोर्स सोल्यूशन अगर मैं बोलूँ तो क्या होना चाहिए लॉजिकली, क्या होगा ब्रूट फोर्स सोल्यूशन? ब्रूट फोर्स टफ है इसका सोचना. एनीवेज मूव करते हैं नेक्स्ट में. चलो लेट्स गो टू द नेक्स्ट. आई विल आस्क यू, आई विल आस्क द सेटर टू लीव द कोड, ठीक है. आई विल आस्क द सेटर. लॉजिकल एरर नहीं है, लॉजिकल एरर नहीं है, कोडिंग में कुछ एरर होगा. लॉजिक इज करेक्ट, लॉजिक इज करेक्ट. Okay, let's get to the next question. Let's get to the next question and try to solve it. अगर तुम लोग बोलोगे नेक्स्ट दिन तो मैं क्या करूंगा, मैं भाई एक बार कोड रेडी रख के आऊंगा. Coding live teaching is not that easy because every time I code I need to explain you, so it's not that easy. Specifically in जब आप कोड लिखते हो आपको चाहिए रहती है शांति. तो इस क्वेश्चन को समझते हैं. So basically the question states there are n cities in Geekland numbered 0 to 1. अरे नितिन यार बड़ा परेशान कर रहा है. क्या हो जाएगा यहाँ पे, सबमिट देख लेगा तू, अलग लेवल है. लॉजिक देख लिया, कोड का लिंक डिस्क्रिप्शन में डाल दूंगा, चेक कर लेना ना बाद में. Why suffix plus 1? Because Amrita, whenever we do a partition, I'm asking from this pick the n greater elements and from this pick the n smaller elements. So I was storing over here the n smaller element sum, right? So that's why I'm assuming I'm over here. So I pick up this guy as the greater element and then I go to I plus 1 and pick up the smaller element. That's why. Got it? Got it, Bharat? Got it? Everyone who was asking this. Okay? Cool. So we will move on to the next question. There are n cities in Geekland numbered 0 to 1, n minus 1. There are n minus 1 bi-directional routes. ठीक है. अरे यार पता है बहुत स्पैम करते हो. मेरे को नेक्स्ट दिन से ना मैं 2 मिनट का वो लगाऊंगा. काफी स्पैम करते हो तुम लोग. जबरदस्ती स्पैम मत करो प्लीज, प्लीज प्लीज प्लीज. Okay, there are n cities in Geekland numbers 0, 1, n minus 1 with n minus 1 bi-directional routes. So the moment the question states ki n minus 1 cities are 0 to n minus 1, it refers to a graph. And the next is n minus 1 routes The moment it states this, it's a tree. It's a tree. Okay, the first thing is it's a tree, because the moment I say there are n nodes and n minus 1 edges and everyone is reachable, to each other, it's a tree. If everyone is reachable to each other and there are n nodes and n minus 1 edges, it has to be a tree. It has to be a tree. Okay, it has to be a tree. So what is the question stating? I'll explain you. So basically the question states, assume this is a tree given 0 1, 0 2, 1 3, 1 4. Assume this is the tree given. Okay, first query states, the first query states, remove the vertex 0 to 1, remove this vertex 0 to 1. So assume this portion is deleted. Assume this portion is deleted. Tell me the maximum distance from the city 0. Tell me the maximum distance from the city 0. And the maximum distance is 1, because this portion does not exist. Because this portion does not exist. Okay, perfect. 0, 1, 3, 4, 2. Let's have the next query. Next query is 1 to 4. So they're saying remove 1 to 4. So remove this. So if I remove this, which is the longest path? Can I say this is the longest path in the tree from 0? Can I say it's the longest path from 0 to 2? Can I say this? Can I say this is the longest path? Thereby, this is what I print. So after removing every edge, I have to find the longest path from 0 to any node in the tree. Is the question clear? Is the question clear? Is the question clear? Is the question clear to everyone? After removing the longest path, you have after removing the path, you have to find the longest path. UQ to everyone. Shall I move to the explanation? It's a very easy question. It's a very easy question. Prerequisites of the DFS in a tree. DFS in a tree. Prerequisites is a DFS in a tree. It's a very, very easy question. Remember, every query is independent. Every query is independent. Every query is independent. Okay. So let's take a tree. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So guys, I'm asking you a very simple question. This is the tree given to you. And assume the query that I give you is remove 1, 3. Remove 1, 3. Tell me what will be the answer. Let's see if you've understood it. Remove 1, 3. I am asking you to remove 1, 3. What will be the answer? Remove 1, 3 means remove this. So if I remove this, my bad, I forgot. I mistakenly erase this. Perfect. Amazing, amazing. Yes. Yeah, 2. 2 is the answer. Perfect. So if I say remove 1, 3, what happens is, you said this portion is removed. That means this entire tree goes off. Now, the longest path from 0 can be this, which is 2. Can be this, which is 2. Can be this, which is 2. Perfect. Everyone has understood the question. Amazing, amazing. Okay. So since everyone has understood the question, now I'll try to explain you the question in a very, very simple way. Very simple. Okay. But before that, let me teach you what is a Euler tour. Because if you know Euler tour, this becomes a cakewalk. If you know Euler tour, this becomes like a cakewalk. So 8, 9, 10, 11, 12, 13. Okay, what is an Euler tour? Euler भाई जल्दी बोल, कल सुबह पनवेल जाना है. चल जा, स्ट्रीम तो सेव रहेगा. So this is the node where you start the DFS from. So remember, whenever you start the DFS from, this is where you start the DFS from. Write that guy. Write that guy. 0. Next, you go here. DFS, you know, no? Left. You go on to the adjacent nodes. Then you go to 2. Then you come back to 1. Because you go like this, then you go like this, then you come back to 1. By the way, prerequisites are DFS in a tree. You must be knowing DFS in a tree. Then you go to 3. Then you go to 4. Then you go to 6. Then you come back to 4. Then you go to 7. Then you come back to 4. Then you go to 3. then you come to 5, then you go to 3, then you go to 1, then you go to 0, then you go to 9, then you go to 10, then you go to 9, then you go to 11, then you go to 12, then you go back to 11, then you go to 13, then you go back to 11, then you go back to 9, then you go back to 10, right? Why is this guaranteed to be a tree? Because n nodes, n minus 1 edges, and it is guaranteed that every node is reachable from every other node, so it has to be a tree. Otherwise you can't draw a possible graph where every other node is reachable to each other. Where is 8? अच्छा 8 गए नहीं, 8 भूल गए जाना, अरे चले जाना 8, अरे भूल गए वो रास्ता भूल गए लेना, और समझ में आ गया यूलर टूर क्या है? भूल गए वो रास्ता लेना. I'll have to use a bigger blackboard. अरे भूल गए भाई, 8 का रास्ता भूल गए लेना, सॉरी, माफ करो, माफ करो, माफ करो. जान ही ले लोगे तुम लोग, एक मिस नहीं हुआ पूरा बरस जाते हो. भाई साहब ने गलती किया है, पूरा बरस जाओ इस पे. ये नहीं दिख रहा है 1500 लोग को टैकल करना कितना टफ है. Okay, so if I try to write the Euler tour of this, can I say the Euler tour of this will be 0, 1, 2, 1, 3, 4, 3, 5, 3, 6, 3, 1, 0, 7, 8, 7, 9, 10, 9, 11, 9, 7, 0. How many of you agree that this is going to be the Euler tour of this? How many of you agree that this is going to be the Euler tour of this? How many of you agree? How many of you agree that this is going to be the Euler tour? No, it can be any tree. It is not a binary tree. It is not a binary tree. This is the Euler tour because 0, 1, 2, 2, 1, 3, 4, 4, 3, 5, 3, 1, 0, 7, 8, 7, 9, 10, 10, 9, 11, 11, 9, 7, 0. Euler tour, right? Perfect, perfect, perfect. Amazing, amazing, amazing. So this is definitely the Euler tour. Now assume, I say, while computing the Euler tour, just write down the levels. Just write down the levels. Can you write down the level of every node? You can. This is level 1. This is level 2. This is level 2. Level निकालना तो ट्री में आना ही चाहिए. Level 3, right? This is again level 3, level 3, level 4, level 4, level 4, level 4, level 4. Can I say these are the levels? Can I say these are the levels of these guys? I can definitely say. ये थोड़ा सा यहाँ पे ट्री वैसा हो गया 7, 8, 9, 10, 11. ठीक है, इसको थोड़ा सही कर देते हैं तो समझने में बेटर होगा. 7, 8, 9, 10, 11. So level, right? You can easily get the levels. Now your task will be, see, what you need to do is, you need to write this is the Euler tool. For this, try to write down the level. Try to write down the level. Okay. So for 0, the level is 1. For 1, the level is 2. For 2, the level is 3. For 1, the level is 2. For 3, the level is 1, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 4. So I know all the levels. Okay. I know all the levels. So what I'll do is, I'll say, okay, I'll write down the levels. Very simple है. DFS में सिर्फ एक दो लाइन चेंज करना है, Euler tool निकल जाता है. 3 का लेवल कितना है? 3. 4 का लेवल 4 है. 3 का लेवल 3 है. 5's level is 4. 3's level is 3. 6's level is 4. 3's level is 3. 1's level is 2. 0's level is 1. 7's level is 2. 8's level is 3. 7's level is 2. 9's level is 3. 10's level is 4. 9's level is 3. 11's level is 4. 9's level is 3. 7's level is 2. 0's level is 1. So I've written down all the levels. Okay. Now, what does a Euler tour signify? Let's understand. So please be careful. So if I say 1, find the first occurrence of 1. This is the first occurrence of 1. Find the last occurrence of 1. This is the last occurrence of 1. So this entire thing is the subtree is the Euler tour of the subtree of 1. This entire thing is the Euler tour of the subtree of 1. You can check 1, 2, 1, 3, 4, 3, 5, 3, 1. Do you, oh sorry, 6BA, 6BA. So 1, 3, 1, 3, 4, 3, 5, 3, 6, 3, 1. Entire thing is the Euler tour of this particular subtree. Do you see this? Do you see this? This entire thing is the Euler tour of this subtree. You do see? So I know one thing. For a node, if I can find its beginning and if I can find its ending, if I can find its beginning and if I can find its ending, I know that portion of the subtree. I know that portion of the subtree, right? Okay, perfect. Let's remove this. Somewhere down the line, a query comes in. Okay, so somewhere down the line, a query comes in, and the query states me, "Hey, Striver, can you remove 1, 3? Can you remove the edge 1, 3?" Someone did come up and say, "Hey, Striver, can you remove the edge 1, 3?" I'm like, "Okay, I'll remove the edge 1, 3," which means this edge, which means this edge. So removing the edge 1, 3, is that equivalent to removing the subtree 3? Is that equivalent to removing the subtree 3? Very important, not subtree 1, because the 1 has different branches. It's equivalent to removing the subtree 3. Can I say it's equivalent to removing the subtree 3? Can I say this? I can definitely. So where is 3? 3 is here, the first occurrence. Where is the next 3? Here. So I just need to truncate this. I just need to truncate this. Truncate. I just need to truncate this. So I know, I have truncated the subtree 3, right? Now this portion is nothing but this portion, and this is the remaining tree, right? So what do you wanted? The maximum distance. Can I say out of this the maximum distance is 3? Out of this the maximum distance is 4. So what's your answer? What's your answer? What's your answer? What's your answer? How was it? Maza aaya? No need of segmentary. No need of segmentary. You can just store prefix max. Just store prefix max. Just store suffix max. And if you know the beginning, if you know the ending, then the answer will be max of prefix of beginning minus 1, comma, suffix of end plus 1. Got it? Yes. I'm not sure of different approach. The easiest approach is this. Like if you've done CP, like I teach in my, like जब मैं CP पढ़ाता था, CP कोर्स में मैं ये पढ़ाता था, and I used to do these kind of questions. तो निशांत अगर चैट में था, मैं तब देख रहा था, तो निशांत ने ये किया होगा, you. How do you get the end of the subtree? It's very easy. If they asked you for 1 and 3, figure out which is the highest level. Like 1 का level कितना होगा, 2 होगा, 3 का level 3 होगा, तो ये बंदा नीचे होगा, ये बंदा नीचे होगा ना, तो इसका डिलीट कर दो, 1 का डिलीट मत करो. The guy who's at the, okay, why beginning minus 1? Because you don't want to consider this. You just want till here the maximum and till here the maximum. Yeah, Sandeep, you can do it your way. I have my way of doing. You can do it your way. These are the problems that I did set this code. So this was the problem set is. So without Euler tour, not sure. I have to think. Because the moment I read the question, the first thing was subtree हटाओ, आंसर निकल जाएगा. तो पहले दिमाग में वही आता, जब आप देखते हो कि हटाना है एज, तो सबट्री हटाने का कॉन्सेप्ट आता. सबट्री मतलब यूलर टूर कॉन्सेप्ट जुड़ जाता है. इफ यू हैव डन सीपी. No, haven't done. Okay, so let's quickly code this. I'll just give you a overview. Like, so basically it's given edges, queries and n वगैरह दिया हुआ है. So you need to create the graph. First you need to create the graph. So please create the graph. So like adjacency 10 to the power 5. So yeah, 10 to the power 5. 1 1 1 1 3 4. Perfect. I've created the adjacency list. So you can just create the tree. So just go on and create the tree. Like order of id edge, and you can be like adjacency of id dot first dot push back of id dot second, and similarly adjacency of it dot second. You can just do a push back of बहुत लंबा कोड होगा, मजा थक जाऊंगा मैं कोड करते करते. ठीक है, how to form this tree? Tree created, adjacency list declared, tree is created. Now once the tree is created, what's your thing? You have to store the euler tour, right? So probably you can just do a vector of int of euler tour, and you can write the void dfs. You can also keep something like vector of visit, and I'll just keep it like 1005 comma 0, and the dfs could be from the node. You have the adjacency list. Do you need anything else? I don't want to go back to the parent because it's a tree. That's fine. I'll just create. Okay, fine. As a visited of node equal to 1, I'll just again dfs लिखने के अपने अपने तरीके हैं, तो प्लीज कमेंट्स में ज्ञान मत देना कि ऐसे मत लिखो ऐसे मत लिखो. If not visited of it is dfs of it. Yeah, I think this is the standard dfs that you write. This is the standard dfs that you write. And now how do you insert euler tour? So it's once while entry. So you can just write euler tour dot pushback once while entry, pushback of node, and once while you come back of it. So euler tour dot pushback once while you come back. So euler tour dot 4 से 3 आया, 3 से 5 आया, एक से 3 गया आया गया आया गया आया. हाँ तो so euler tour dot pushback, you can just give it, you can either give it here, or you can, for a better, like if you want a better version, you can give it here. This also works. Yeah, that's how you can easily do it. Like once it goes inside, again gets a new one. When it comes back, you can give it here, or you can just give it because you're considerable subtree, so you can give it as well. Yeah, okay. So this is how you can easily, just couple of lines in the dfs. This is entry and this is exit. So if you store this, the euler tour should be ready. The euler tour should be ready. Now you just need to store the level. So really you can just do the level equal to 1 initially, and you can do vector of int of level 1000 again 5 comma 0, and you can always do this as level plus 1 because in tree that's how you go. And you can do develop node equal to level. Perfect. So that's how easy you can just store the level. So I've made sure I've stored the euler tour as well as the level. Now what I need is I need the beginning index. So I can probably keep a map of int map of intent and map. Perfect. I can definitely do that, and I know this is the moment. So oh my, okay. So euler tour dot pushback. I need the indexes, right? Okay, I'll start and cool. Once I've done the euler tour, I can just traverse in the euler tour only. Euler tour, you can traverse in the Euler tour, and you can say if map of it, sorry, if start is not there, start of it is equal to null. You can say start of it equal to index equal to I, and you can probably keep the index as int I equal to 0, and you can just do an I plus plus, and you can always do the end to be I. So end will be updated every time, end will be updated. So this is how you can easily store it, the start and the end. So the start and then start, you'll just store it for the first time, end just keep on updating every time you will be doing it. Okay, so this is how you can get the beginning. Now it's time to get the prefix max. So yeah, just go across to the entire Euler tour, and you can just compute a prefix max, pre-max. You can just do it like Euler tour dot size. Hello, na? थक गया मैं. You guys will be able to do it. Oh yeah, fifth Thomas. So once you do this, it's going to be a cakewalk. So just store the prefix compute prefix. मैं और नहीं लिखने वाला. Similarly, compute suffix max. Okay. हाउ लाइन 27 वर्क आउटसाइड ऑफ फॉर लूप. तो अगर आप 27 आउट, क्योंकि मुझे एग्जिट चाहिए था तो मैंने क्या किया, मैंने ये हटा दिया. मैं जैसे अभी क्या कर रहा था, मैंने यूलर टूर पे व्हाट आई वाज डूइंग वाज आई वाज स्टोरिंग लाइक 3 4 3 5 3 6. So I saw that 3 4 3. So this 3 is not required so many times. So what I'll do is I'll be like 3 4 5 6 and then 3. I'll go to the depth of the subtree and then I'll come back. So that's why I kept it outside the for loop. Got it? सही है, कोड सही है यूलर टूर का, कोड सही है. देखो डिपेंड करता है, अगर तुम फॉर लूप के अंदर दोगे, अगर तुम फॉर लूप के अंदर देते हो जो अपना यूलर टूर है, तो क्या होगा पता है, व्हाट विल हैपन इज, तुम यहाँ 3 है, फिर 4 पे जाओगे, फिर वापस 3 पे आओगे, फिर वापस 5 पे जाओगे, तो बहुत सारा 3 का ऑकरेंस रह जाएगा. सो दैट्स व्हाई व्हाट आई डिड वाज आई गिव इट आउटसाइड फॉर लूप. दैट्स व्हाई इट्स बी लाइक 3 4 5 6 एंड देन इट विल कम बैक टू 3. गॉट इट? So सही है, मतलब you can write it any either ways, it's fine. So compute the suffix max. Once you have computed, you have to just iterate and answer the queries. Query ये ना, and you just need to figure out the node. So as of now, assume the node to be IT of 0, and if by chance your node comes out to be greater, like the other node is on the downer level, just replace it. Always take the guy who is at the bottom, because the subtree will be subtracted. Done? Perfect. So once you've done this, get the maximum, like beginning index will be start of node, end will be end of node. And once you've got this, the answer will be max of prefix big minus 1 and sub of n plus 1. Just make sure you check for beginners minus 1 should be greater than 0 and n plus 1 should be smaller than that. Check for big minus 1, check for edge cases when big is 0. Okay, check for edge cases like these. Okay, समझ में आ गया ना, लॉजिक समझ में आ गया. Time complexity, this will be big of n. BFS takes big of n. This will be big of n. Then this is another big of n. This is also big of n. Yeah, everything is big of n. And then you're answering the query in big of 1 for every query. So yeah. ग्राफ सीरीज में मैं डाल दूंगा इस बार, ग्राफ सीरीज नया आ रहा है ना, उसमें डाल दूंगा. ठीक है, उसमें डाल दूंगा, डोंट वरी. Did you like the third question? I told you now, third question, if you know, it's easy. If you know, it's easy. If you know Euler tour, it's like easy peasy, because you just have to think, just subtract this, store the levels. It's kind of, you have to be good at implementing, otherwise you'll not be able to. You have to be good at implementing, otherwise you will struggle. So if you want to read Euler tour, there's a wonderful मैंने यहाँ से सीखा था algorithms. Yeah, यहाँ पे भी है, यहाँ पता नहीं, ये लोग यूलरियन पाथ निकाल रहे हैं, बट ठीक है, यहाँ पे क्या दिया, ये सेम कॉन्सेप्ट यहाँ पे भी सिखाया गया है. यहाँ पे इन्होंने अंदर ही डाल दिया, मैंने बोला ना अंदर भी डाल सकते हो, बाहर भी डाल सकते हो, आपके रिक्वायरमेंट पे. यहाँ पे भी यूलरियन पाथ सिखाया गया, सेम चीज़. इन्होंने थोड़ा अलग स्टैग वगैरह से किया, मुझे नहीं पसंद. कहीं से तो मैंने सीखा था, तो जीएफजी से सीखा था, यहीं से सीखा था. ये देखो, यहाँ पे भी डाल सकते हो, बाहर भी डाल सकते हो, डिपेंड करता है आपको कितना बार चाहिए. हाउ वाज टुडे? डिड यू एंजॉय यूलर टू, लर्निंग यूलर टू? Yeah, I'll add Euler tool in my graph series and I'll do the same problem. Okay, I'll do the same problem. Chalo, done. I am thinking of making a new playlist entirely. I'll bring it in this month complete. Don't worry. Did you enjoy? थोड़ा tough हो जाता है. Trust me, when there are 1500 people, it's very tough to code. You need to understand. I'm explaining you. I'm teaching you from 1 hour. आप खुद ही सोचो ना, आप जब कोड कर रहे होते हो तब आपके सामने कोई आके मचर मचर कर दे तो आपका दिमाग दही हो जाता है. और मेरे को तो मतलब आप लोगों के सामने पहले तो समझाओ आपको, फिर कोड करो. इट बिकम्स क्वाइट अ टीडियस टास्क. सो दैट्स व्हाई तो क्या मैं बहुत प्रीफिक्स सफिक्स वाला अगर कॉन्सेप्ट नहीं हो रहा है तो फिर दिक्कत है. I think this last question was tough. Uh, the last question was tough. If like you have to be versed with CP, otherwise the last बहुत tough था. I was talking with the problem setter. I said Amazon wanted some tough questions, so that's why he had to set up something from graph. No audio. Where else you can use Euler to, like in most of the questions where there is a uh, routing of subtree, in most of the questions where they deroot the tree from a node, that's when Euler 2 comes in, because it basically means just take out a subarray and that tree is off. So in most of the questions where they will be like take out a node, delete a node, something like that, always. Okay. प्रीफिक्स सफिक्स, अरे प्रीफिक्स सफिक्स नहीं आता तो ये ट्री मत पढ़ो. प्रीफिक्स सफिक्स नहीं आता तो ट्री मत पढ़ो. ग्राफ की प्लेलिस्ट आ रही है. ग्राफ की प्लेलिस्ट आ रही है. Anyways, for anyone who's new out here, you can check out my channel, Take You Forward. I put a lot of content over there. You can follow me on LinkedIn as well. Probably they would have put up my link. वैसे मेरा नाम ही नहीं ऐड किया. क्या बात करो. कोई नहीं, मेरा नाम लिख लेना, राज लिख लेना, आ जाएगा. राज विक्रमादित्य लिख लेना, स्ट्रेवल लिख लेना, लिंक्डइन पता चल जाएगा. ठीक है, चलो कोई नहीं, मिलते हैं अगले जॉबाथॉन एडिटोरियल में. तब तक बाय बाय, टेक केयर, गुड नाइट.